Some introductions first. My name's Andy Hadamer. I'm the head of community here at Materialize. I'll be going through the intro and then handing it off to our director of field engineering, Krishna Manoharan, to go through the e-commerce demo. All right, so let's get started. Just at a very high level, what is Materialize? There's no great category name for it yet. Database and stream processor each come with their own sort of misleading connotations. So I'm going to take the next few slides to break down the different parts of this explanation here. Materialize is an engine for maintaining views on streams of fast changing data. So going into the streams of fast changing data first, what we mean by that is the data inputs for Materialize, or sources as they're called in Materialize. These are event streams like Kafka and Kinesis primarily, but also archived events from S3 or local files. And the formats of these, this data is Avro, Protobuf, JSON, CSV, or even raw text. And one new upcoming thing that I'm particularly excited about is direct Postgres source integration with Materialize. So if you're not already a big Kafka user and you really need just to connect Postgres and Materialize, today you would need to set up a change data capture system like Debezium and Kafka. In a month or so, at least in the experimental mode, we will have a connection directly from Materialize to Postgres, where it's basically just reading from the Postgres write-ahead log. And the types of data that Materialize handles well are change feeds from databases. That's the architecture with a database and then a change data capture system going into Kafka. And more broadly, just any kind of fast changing data from web, mobile, gaming, or IoT. And even more generally, if Kafka is already sort of the spine of your architecture, you probably have a lot of data in there, and there's probably a lot of business value to be had in being able to materialize views of that data in real time. So what do we mean by views? This is sort of the core way in which you use Materialize. You use it by creating materialized views of the data. So a view distills the raw data into whatever end form you need, and that's done in Postgres compatible SQL. And the big difference between a materialized view, if you're familiar with it from the traditional database world, and here, is these are updated in real time. And the results of these views can be queried much like you would a traditional database, or they can be streamed out into a new Kafka topic. And getting into that real-time aspect of it a little bit more. So this is where the maintaining aspect comes in. Materialize is continually updating the views, and the only way it can do that is by using incremental computation under the hood, where the work to maintain a view is proportionate to the new data coming in and not the scale or size or complexity of the view. And lastly, we're calling it an engine because Materialize runs as a single binary. It presents as Postgres, and you connect with pSQL command line or any other SQL tool and integration. We recently added an integration for a really great data modeling tool called dbt. And it's also an engine in that users specify what they need in SQL, and Materialize handles how to get it. And it's more of a query engine than a storage engine. We're not currently focused on warehousing long-term data. Views are materialized in memory, and all the data you want to materialize has to be in an upstream database, Kafka or S3. Okay, so that's like a very broad coverage of what Materialize is. Now, more importantly, what can you do with it? You can build better data products. And by data products, if you're coming from the data engineering side, I'm talking about things like real-time analytics dashboards, operational analytics, real-time enrichment, internal analytics APIs, all of these things that as data engineering teams evolve to building more products, they're basically like an evolution of what they're providing. And if you're coming from the software engineering side, Materialize is a really great fit for data intensive applications. So microservices that are consuming from Kafka and doing anything that looks like a query, real-time applications, user-facing real-time analytics, customer data platforms, basically anything that has a serious data dependency. And better, what do we mean by that? It's simpler. It's often reducing the need for larger infrastructure or replacing multiple services or just doing what you would otherwise depend on complex caching or denormalization for. And there's an existing, there's a good integration story with lots of existing SQL tools that have been built up over the last 30 years. And the accessibility of Materialize is broader than that of a stream processing tool where there's a very small set of engineers that are able to work with them. And it's better because it's fast. The time lag between input and output is typically in the low milliseconds. And a query to a materialized view is similar to fetching from Redis, where very little compute is happening. So you can expect low latency and high volume is fine. And it's also better because it's powerful. Materialize is strongly consistent. Eventual consistency has some unexpected effects in the streaming world. One of our co-founders, Frank McSherry, has a really great article on this. If you Google eventual consistency isn't for streaming, you can read it. And then it's also powerful in that it's SQL with fewer limitations. So it can do complex joins and aggregations where a lot of SQL-like languages sort of fall short. And lastly, under the hood, by building on top of differential data flow and timely data flow, there's some powerful scaling features like shared arrangements that help you add more materialized views without necessarily running into limitations. Okay, I'm gonna hand it over to Krishna to go through the e-commerce demo.
Thank you, Andy. Let me share my screen.
We can see the SQL pad.
Yeah, I'm trying to move this toolbar around. Hold on. Okay, good.
You're muted, Krishna.
Right. So today we are going to look at to see how we can build a real-time app to solve a problem pertaining to an e-commerce business. When you are running an e-commerce website, you would like to understand like what are your top items that's being bought today? Is there a particular trend that you want to discern? Do you have enough inventory in order to manage this demand? If you're running short on inventory, how would you to manage it? Can you place orders directly with your suppliers as and when your inventory runs low? One would also want to know as to how effective the website is. Like, are you actually able to convert viewers of website to actual buyers of a product? So these are fairly common questions that business would like to understand. And let's look and see how we can solve it using Materialize. This is an overview of what we're going to do today. The box in blue is what I'm going to be showing you. We have other components like a website and Kafka. We have automated that part for this particular demo, and we have real data flowing into Kafka. On the Materialize side, we will create Materialize views. We will then subscribe to those updates and show them using a real-time dashboard for some parts, for some of the questions. And for some of the other questions, we will show how you can create a microservice based on the data. So we identified several problems at the beginning. Let's break them down into a dashboard type problem or a microservice type problem. For visualizing order trends, category and item trends, as well as website funnel stats, these are best seen on a dashboard. So we will use Metabase and show a real-time dashboard for these questions. For the other two questions, as regarding inventory status, to see if your items are running short and to place an order automatically with your downstream supplier, as well as showing inventory status as and when a user is actually looking at a website, at a particular object in a website, to determine if he needs to go and place the order right away or he can wait. We can use a microservice for that as well. For that, we will use GraphQL. So what I'm showing here is that you have the ability to extract information out of Materialize in multiple different ways. The dashboard is a fairly simple way of taking data out. You can use plain SQL, run queries on Materialize, on the Materialize views that you have created, and display them in a dashboard. For microservices, Materialize allows you to write out automatically. It allows you to write out the changes on these Materialize views, and you can write them out to files if need be. You can write them out to Kafka topics if need be, and so on. You also have the ability to integrate Materialize with GraphQL, which gives you a fairly easy way to subscribe to changes as and when they happen. Let's quickly go through the data that we're going to be seeing today. We have our primary source of data, which is user behavior. It's transactional data. It's in JSON format, and it has got 5 fields. We've got secondary dimensions that we can use in order to enrich this feed that's coming in. So all of this is in Kafka today. And what I'm showing you here is CalfDrop, which is a fairly trivial way of displaying messages as well as showing you what topics are available for you to consume. As you can see here, I've got 5 topics: category, inventory, item, subcategory, and user behavior. If you go into user behavior, which is transactional in nature, we can see that the format of the data is JSON. It pretty much gives you user ID as to which specific user, item ID, which item the particular user is looking at, and category as to whether this item belongs to which category, and then basically behavior and timestamp. Behavior here is page view, PV stands for page view, favorite stands for favorite. We have other topics here as well. This is category dim, which basically tells you which categories are available. Like, for example, books is category 1. So what's going to be our plan of action? The first step is to download Materialize along with Metabase. Metabase is an open source BI visualization tool. It integrates natively with Materialize today. We will then create the sources and Materialize views. We will create the dashboards. And then finally, we will create a sync to file for inventory updates. The physical requirements or the OS requirements for running Materialize are trivial today. You should be able to do this workload with a small configuration as seen on the right. Let's go a little bit deeper into how we will actually create these views in Materialize. Materialize today is an in-memory today, in the sense all the data or all the structures are stored in memory. So we would like to be precise. We would like to make sure that we are able to use the environment that's available to us as efficiently as possible. So when you use Materialize, we would like to break it down into multiple steps. The first step is to create all the sources. Sources here are that which is in Kafka or files on disk. We then create relevant views. These views, you can think of them as your first level of filters. Materialize excels in capturing updates to data. So we would only want to capture or filter out areas of interest from these sources. And then finally, we create Materialize views. These Materialize views would allow you to subscribe to changes as and when they occur. And you can use these Materialize views in order to power your dashboards or microservices. Okay, so let's go on to the actual deployment state. So what I have here is SQL Pad, which is an IDE that works well with Materialize today. I've got all the DDL here. So the first step is to create all these sources. As you can see here, I've got several sources, all of them connecting to Kafka. They are subscribing to different topics. We have user behavior, which is your transactional data, format JSON. And then we have got 4 other dimensions, which are CSV format. So the sources have been created. Once we create the sources, the next step is to create views. These views, again, allow us to filter out data that we are interested in. They are like a second level of abstraction that we would like to do. We can create indexes on these views. These indexes would help with joins or specific filters when they are being used.
Krishna, are you able to zoom in a little bit on SQL Pad to make the text larger?
Let me do that. Yes, okay. For some reason, this doesn't allow me to do it. Oops. Is it better now?
There you go.
Okay. As you can see here, the final view actually is joining all of these dimensions and the transactional data together. Materialize will then maintain this view for you. So once we have created the basic underlying views, we then can create materializations for those questions that we are interested in. The first one, what I have is by activity time. That is telling us like how many orders are being processed at what specific time. This allows you to see a trend, like whether, okay, I'm busy during morning hours, whether it's in the afternoon hours or late night, and related. I got several of these questions here. The second one is by top categories. That is to identify which categories are selling the most and what specific times. The next question for our dashboard is by items, as to seeing which items are the ones that are selling the most. Let's go ahead and create these. Okay. The next question that business is interested in answering is to see how effective the website is in converting a page view, wherein which a user actually views an object and then does a buy decision on that. As you can see here, the SQL that is being written in order to answer this question is not what I would say overly complex, but it's not trivial as well, in the sense that we do have We have account distinct. We have two subqueries, which are then being joined together. The last one is about inventory status. So now that we have created all these materialized views, let's see what are the views on the system. It shows us all the views. Show full views on Materialize tells you all the views that have been created. And if you see a true next to the Materialize column, it means that it is a materialized view. If it's a false, it means that it's just a regular view. A regular view is used in order to basically make it easier for you to understand, or it's like a level of abstraction that you're using with Materialize here. Let's now see if we are actually having data in these Materialized views. As you can see here, the data is now being populated, and this gets updated as and when we start seeing data streaming in. Let's look at the top categories. Okay. And so forth. Let's see data and dashboard. What I have done is I've taken all of these questions and I've created a dashboard using Metabase. You can then have this refresh every minute as you see fit, and you're now able to run queries against Materialize and display the results in a dashboard. The queries that you're running, if you are now trying to run the same thing on, say, Postgres, you're going to be having to do the computation at every run. Here in Materialize, the advantage is because the views are persisted and in memory, they're being maintained for you as and when data changes. The cost of running a query like this is fairly trivial. So in a matter of few minutes, we are actually able to create a real-time dashboard from streaming data. We are able to answer business questions which are not easily answerable using other technologies. So to go back to our presentation, so now we have the dashboard done. Let's look at the next problem that business is looking to solve. They're interested in seeing inventory status, and if a particular item is running low on stock, then to automatically create an order with the supplier. So for this, what we are going to do is we are going to create a sink. A sink is a way for writing data out as and when it changes onto a target. A target here can be a file on disk, as this particular example shows. It can also be Kafka that you can write out, and we soon will have the ability to write out to S3 as well. As you can see here, we create a sink. It's a file on disk, which is continuously updated. You can then tail this file and capture changes to items that need restocking. This is the output that you'd be seeing in this particular file. You can see here that a particular item ID, which has got a name of electronics item, needs to be percentage sold is 82%. Hence, it is running low on stock. So you would need to place an order in order to have your supplier restock the warehouse. Now, one way of actually writing out changes is using sinks, in which case you can then have downstream suppliers.
Krishna, can you show this in full screen just because it's hard to see?
Yeah. Okay. So there's one way of capturing changes is using sinks. The other way of capturing changes is using PostgreSQL, GraphQL, and in this case we are using PostgreSQL. PostgreSQL is a GraphQL server which connects or works with Postgres today, it will work with Materialize as well. With GraphQL, you have the ability to create subscriptions and get changes or subscribe to changes as and when they happen. So a good way of using this is, as the graphic on the right shows, you have this blue box saying live inventory 60 or 59 in stock. You have the ability to update that in real time as and when changes occur. So this integration, I can as well show it you here live. So you have here a GraphQL IDE, and you can see here that all the views that we have created earlier, they are available for you, like your buy activity times, top categories, top item days, items inventory, and restock. So you have the ability to integrate GraphQL with Materialize today and use that as a third way to extract changes out from Materialize. Let's look at the last part, that is monitoring Materialize. Materialize exposes some data through port 6875. You can then access this using a browser, as you can see here. Let me make this bigger for you. Okay, as you can see here, we have server status, which tells you if the server is up or down. It tells you how many queries it has handled so far and how long it has been up for. It gives you other statistics such as bytes read, command duration, and related. It gives you Prometheus metrics. So you have the ability to actually use Materialize with Grafana and Prometheus. You can configure Prometheus to scrape this particular URL and extract changes, extract the data out, and display it using Grafana as well. You have memory visualization, which tells you the actual cost of running a Materialize view. Here you can see that all the materializations that we have created, it has got the data flow ID, the index name, and the number of records. So the first particular data flow is the one which has the maximum number of records, and you have the ability to take a peek at it and see, what are the operations that is powering this particular data flow. Which particular operator is the one which has the maximum number of rows? As you can see here, it's the arrange operator. So you have the ability to monitor Materialize as well using this particular HTTP interface. Okay. And lastly, you have the ability to also use Grafana with Materialize, provided you have configured to scrape Prometheus metrics and display it using Grafana. Okay. So I'm now going to hand it back to Andy for the next part.
All right, thanks, Krishna. By the way, if I heard feedback from a few people that they were having issues reading the text, we'll share out a high quality version of this after the event so that you have access to that. I think it's variable, but depending on everyone's internet connection. Okay, let's wrap up here. So just to summarize what we went through, anyone can install and run Materialize today. It's source available and it's free forever to run on a single node. It reads from Kafka, Kinesis, S3 and local files, and you are querying results via SQL or streaming results out to new Kafka topics or files. And Prometheus and Grafana, there's pre-configured endpoints to integrate with those for monitoring. And in terms of what's coming in the next few months, Postgres replication, as I mentioned before, improved Kafka syncs, so improved output streams, and long-term more inputs. So all of the other message broker formats and more integrations and generally more persistence features. And just that quick shout out to Materialize Cloud. So if you're interested in using Materialize, but as a managed instance that's just available or configurable in a web UI in AWS, register at materialize.com/cloud, and we'll be reaching out to people as capacity opens up. Should be in the next month or so. And now let's get into Q&A. We had, I think, a couple questions come in during the presentation. So I will read those out, and Krishna will help me answer them. So one person asked about what is the purpose of creating indexes? Isn't it enough to create only views on top of Kafka sources?
You can. So we think of views as one level of abstraction. You don't need to do that. You can create materializations directly on top of your Kafka sources as well. And having indexes help in other ways, like you can get a more efficient join if you have an index on those columns that is being used for your joins.
And then one person just asked, can you clarify which SQL features are supported and which are not, e.g. joins, aggregations, window, CTs?
Okay, so Materialize today does not support window functions. So that is a current limitation today. Apart from that, pretty much all types of joins are supported, and CTs are supported as well.
And then one person, how far out is full Kinesis integration?
So Kinesis today is in alpha stage. Since that connectivity works, you can connect to Kinesis, you can create views. The basic features work today out of the box. Based on user input and feedback, we can improve it, but right now that's the current state. Hopefully in the next couple of months, it should be more mainstream or equivalent to Kafka.
Great. And then how are people deploying this today without the managed service? Great question.
Self-managed.
Yeah, I think it's, if you go to the docs, there's actually a section on deployment that covers like a few of the common scenarios, but I think, you know, there's, it's kind of variable depending on everyone's existing infrastructure. Any other questions? Okay, we got a couple here. Under what circumstances should I be leaning on Materialize to optimize the data flows that support my views versus setting up intermediary views on my own to make sure my views run well? I'll post that one in Slack because I think that's probably can do some follow up on that. But if I was summarizing, Krishna, it would be, you know, how much do I need to get into the inner workings of Materialize in order to, you know, make sure that I'm optimizing things and using memory efficiently versus just writing SQL?
What I would say is to go about and try the default, that is to lean on Materialize to optimize the data flows. If you would like to improve it further, then we can have intermediate views and indexes on those join columns. So we expect it to work out of the box. We can take a next step forward and optimize it even further. But if the first step works well enough, then I would stop it right there.
And that's a good segue into another person's question. How does Materialize break?
The most common way in which Materialize today fails is when you have an out-of-memory error, in the sense that if you're ingesting large volumes of data and the views are not as efficiently reduced as can be, then your memory usage will grow. And at a particular point in time, when you do not have any more memory to allocate to Materialize, Materialize will get killed by the OS. So that's the common way in which Materialize fails today.
Oh, I think that might be all of the questions from, oh no. How would you recommend handling deploying updates to a materialized view running on a materialized server?
Can we restate the question? I don't understand the ask.
So I think if I'm reading it back correctly, it's, you have a materialized view that's long running and, dependent on downstream in a certain form. And if you're going to be updating it, you're potentially, or just like, what is it's almost like the blue-green deployment type of equivalent for Materialize where.
Okay.
Yeah.
Today, if you'd like to make a change to a Materialized view, then you would have to drop and recreate it. We do not have the ability to alter it in the sense that, say, you want to add a new column to it, or you want to change the definition live without affecting the underlying data. That today is not available. So if you want to make changes to the DDL of a view, then we would require you to drop and recreate the view.
I think any other last questions? I think we've covered all of them, but I want to make sure I give people time to add them in. All right, well, if you do have follow-up questions, join our community Slack and post them there. There's a Materialize channel. We'll be happy to answer them, and those will also get in front of our larger team. Oh, I got one more before we wrap. Does Materialize need to take data from Kafka, or can I ping it somehow via some other API like a Java client?
The upstream sources today that are supported by Materialize is Kafka, Kinesis, S3 flat files on disk. So they are the only ways you can actually load data into Materialize as a streaming ingest. Now you can also do insert to tables. That's the other way of loading data into Materialize.
And the other thing to mention is because it's a SQL interface, there are lots of integrations. It's usually the integrations are downstream, so they're reading data out of Materialize. But even just for updating Materialize or working with it, a lot of the existing SQL tools are either compatible out of the box or don't take too much work to get Materialize compatibility because it's just Postgres. Oh, one last question. Does inserting data, so I guess if I'm rephrasing it, does inserting data directly from Kafka versus some of the other formats like S3 or file have any difference in terms of usability in Materialize or speed in Materialize?
I don't know if we actually handle it differently, if it were coming in from Kafka or from files from disk or from S3 today. But I think we'll have to go back and ask the team if there are enough differences to, to quantify it. But
Yeah,
from my testing, I
I'll
don't actually
post that
think
in
it
the
makes
Slack.
much of a difference.
I'll repost that one in the Slack so that we can follow up. Okay. Thank you everyone for joining. If you're interested in testing Materialize out, materialize.com/start is our documentation page with the install guide and getting started tutorial. You can join our Slack to ask questions and get help from our team and other Materialize users. And if you're interested in the cloud beta, register at materialize.com/cloud. Thank you.